we're going to do today is we're going to walk through a practice problem. This one's taken out of your book, and we're just going to walk right through it. So before we get started, let's take a look at the problem. The average cost of textbooks in the U.S. is $500, and if you've worked with me in the past, then you know I like to create these variable cheat sheets. So I'm going to do that. I'm going to put it down here. The average cost of textbooks in the U.S. is $500. That sounds an awful lot like mu. Mu is equal to $500. Remember, this is mu because I'm assuming that in the U.S. is the population. Okay, population average equals mu, right? Right. All right. Sigma, well, not yet, with a standard deviation of $100. So sigma is equal to $100. So we're good there. Boom. Students, whoops. Standard deviation of $100. Local university wants to test to see if its students also spend $500. This is our statement. This is our comparative statement. This is going to be our hypothesis. Okay, we'll get there in a second. The level of the test is 0.05. That means alpha is equal to 0.05. Let me zoom out just a little bit so I can scroll that up. What else do we know? The university has taken a sample of 75 students. N is equal to 75. This one looks pretty good. And they spend on average sounds like mu or x bar, 540 on textbooks, but they're talking about the sample. So this last sentence here, is about the sample, right? This is the sample. And because that's about the sample, then I know that this is x bar. That 540, this 540 here is x bar. So this is nice little variables that we're going to use. I love my little variable cheat sheet. It tells me what's going to happen in the future. And you know I'm going to do some plug and play with these guys in a minute. But since today we're doing hypothesis testing, it's important to come back and look at our list of hypotheses. We're going to start by doing number 1, which is hypothesis in plain English, and we're going to walk through the entire 10-step process until we get down to the conclusion. This is critically important. This is something that we're going to do the rest of the semester. My stats 2, hypothesis testing, everything is going to follow this process, which is why we're taking extra time to do this now, and we're going to do this with a regular normal standard normal distribution over and over and over again, because when we get to ANOVAs and regressions and multivariate regressions and the complicated stuff, then we've got to have this down. This is important. Okay, so let's begin. I'm going to kind of put this over to one side over here, and we're going to start with number 1. State the hypothesis in plain English. Well, I need 2 hypotheses, right? I need H sub 0 and I need H sub 1. H sub 1 is my hypothesis. What is it that I want to know? And if I look at my question, I know my hypothesis in here somewhere. It is a local university wants to test if the students also spend 500 textbooks. Remember that a hypothesis needs to be a statement. Okay? And so telling me what you want is nice and it's great and all, but what am I supposed to be testing? I want to know if, not a test, not an if statement, it has to be a statement, right? So, do students, nope, that's a question. What if students, no, that's not right either. Statement, I'm making a statement. I believe that students at this university, whichever one it is, spend $500 on textbooks. Why 500 and not 540? 500 because mu is equal to 500. This is the entire United States. Okay? This is the entire United States. So I want to know if my students at my university spend the same as they do in the USA. My null hypothesis, right? This is my null. This is my null. My null is my H sub 0. This, by the way, this could be H sub A. It could be H sub 1. If you have 3 H's, you could have, hypothesis of 2, hypothesis of 3, or whatever, right? So you'll see me use H sub 1 a lot. That's just a habit. And so this is going to be the null hypothesis, then the opposite. Students at the university spend, no, they do not. That's how I do the opposite, right? They do not spend $500 on textbooks. All right, so we're on our way. Number two. Number 2 is over here. Select a statistic. What is my stat? What stat am I going to use? Well, this can be confusing because you don't know if I'm asking for mu or z or whatever. What I'm asking for is which one am I going to compare? Which one am I going to use? Which one am I going to look at? I'm going to look at mu. All right, mu. I'm going to look at mu because that tells me what the average is. In this case, it's going to be mu. And note that number 2 is going to be mu or x bar or sigma, whatever. It is not the actual test stat, which means it's not going to be a z, it's not going to be a t, it's not going to be a chi-square. Okay, this is a statistic that we're going to use. This is a test statistic. Okay, don't confuse the two. All right, number 3. Number 3 asks the question, is this one-sided or two-sided? All right, you can go back over there. Number 3, is this going to be a one-sided test or a two-sided test? Well, the best way to do this, when we go back to our question, the best way to do this is, am I looking for different, or is there a greater, less than? And so here, do I care, let me go over here. Do I care if greater than or less than? Do I care? Do I care that they're spending less than $500? No. Do I care that they're spending more than $500? No. No. I care that they are different. I don't care if it's above or below. I only care that they are different, either above or below, which means that this is a two-sided test. Okay. Number 4, hypothesis in math. Hypothesis in math. And when I say you should be working on this, I mean you should be writing these things out every single time. So when you get to number 4, you should have a list of this stuff. And when you get to number 4, then you write out your hypotheses, but this time it's in math. And if you look at the previous 4 problems, 1, 2, 3, or the steps, then you kind of see what you see that we're going to use a mu. You see that we have a two-sided test, which means equals, right? And you also know, we also know that we're going to use these 500s up here. So basically, we're going to rewrite this guy. We're going to rewrite this guy over here, but we're going to do it in math because now we know. And knowing is half the battle. Always use yours first, right? So now I want to know if mu is equal to 500. And what is the opposite? Mu is not equal to 500. And that is our hypothesis in math. And the reason we do steps 2 and step 3 is so that we can do, this, and we can do this. It makes it a lot easier to put those together. All right, now let's, I would say let's get to the heavy lifting, but we're not there yet. 5 is alpha. What is my alpha? alpha is equal to 0.05. I know that from my little variable cheat sheet. Step 6 is a test stat. And just like we talked about above, right? Stat test is going to be a z or a t or a chi-squared. It's going to be something with an equal sign, right? Z is equal to x minus mu over sigma. It's something that I have to calculate, right? So that's good. It is not going to be, it is not a mu or an x bar, okay? It is not a p. It is not any of those things. It is not something that comes from, it's not something that is descriptive of the population. It is something that we have to calculate, right? So my test stat that I'm going to use here is going to be a z. Why a z? Because the total number of samples in my sample size is greater than 75, because sigma is known. And there are a couple of other videos out there that's going to talk about when we choose a t versus a z. And that's, chapter 9 stuff. So if you go back to stats 1, make sure you understand why we're using a z here as opposed to a t. But let's move on to number 7. 7. Sorry, 6. No, yeah, 7. 7. We are going to use, we're going to determine the critical value. Critical value. Now think about critical values, and now we start drawing a little bit. Critical values. When we have a critical value, what we have is the point at which we start and stop, right? So here's our normal distribution. In the case for this problem, we have a two-tailed test, right? And under the curve on this side, we have 0.0250, and under the curve on this side, we have 0.0250. If I were to go to a z-table, remember our z-tables? Yay! 9, 8, 7, 6, 5, and then there was like 1.6, 1.7, 1.8, 1.9, 2.0, and so on. And there was all these tiny little numbers and decimals over here. It was super confusing. Well, if I were to come in here and find 0.0250, you'd find it where 1.9 and 6 meet. So my z-stat, and it's only because I have this memorized, right? 1.96 or plus or minus z is going to be 1.96. So I know that on my standard normal curve, mu is 0, and this is z sub 1 is going to be negative 1.96, and this z sub 2 is going to be positive 1.96, because obviously it's on either side of 0. The normal distribution is reflective, and that's why we get there. A note on critical values. Oh, this is from before. Let me erase this real quick. A note on critical values. Critical values, or the ones that we use more often, are very common. And so to use a critical value where alpha is 0.20, 0.10, 0.05, and 0.01, these happen all the time, right? Right now we're working on this 0.051, and I know that my critical values or my z's or whatever, critical values of alpha, are very standard. 1.28, 1.65 or 645 technically, 1.96, and 2.57 when this is a two-tailed test. This is for a two-tailed test. And this 1.96 guy right here, this is super common. Happens all the time in science. We see it everywhere in science. We see it in business. 0.05 is a very standard acceptable alpha. It is the level of significance for the test. It is the manner by which we're going to decide whether or not we are correct or incorrect. And when you take your research to somebody else, one of the very first questions you're gonna say, oh, I found all this stuff. And you're like, great, what's your alpha? Meaning, at what degree of significance, difficulty, so to speak, did you conduct your test? And so that's kind of where we are. You don't have to memorize these per se, but you're going to see this guy a lot. You're going to see this guy a lot. You're going to see this guy a lot. And you're going to see it throughout the entire semester. So just remember that this is for a two-tail test, not a one-tail test. And you'll see them all over, so you might as well memorize them. Certainly have them in the bag. They should be on your formula sheets, so you can use them whenever you want. Okay, that was number 7. Let's go on to number 8. 8. What is 8? 8 is compute test stat. Okay, and here is z, right? So we're going to take z, and z is equal to x minus mu over sigma. But in this case, let me put that over there. But in this case, we actually have x bar, right? X bar is equal to 540, right? Look at your variable sheet. And so what we need is to turn this into an x bar, and if we do that, then we need to convert this into the square root of n. But and so that's not difficult. You just have to remember that this is the sample mean, and if we were to do a simple x, it would be a single observation, right? So just keep that in mind. Let's zoom out a little bit and go look at our cheat sheet. All right, let me see. I've never done this before. Let me see if I can. I want to copy. Let's see if this works. And let's see if through the magic of computers, paste, which one of these is paste? Paste, ta-da! Awesome. Awesome. So here's our cheat sheet. I should have put it over there. Okay, fantastic. What happened to my pen? All right, so let's do some plug and play here. Z is equal to x bar is 540 minus mu, which is 500, divided by sigma, which is 100, divided by the square root of n, which is 75. So your Z stat, your step 8 should be something like this, and it's nothing more than plugging and playing. That's why this guy is so critical. When you start at the beginning, write down your variable. I call it a variable cheat sheet. It's nothing more than a variable list, right? But if you have it written down when you start the question and you get to this more complicated step later, which is nothing more than plug and play, it becomes nothing more than plug and play, right? And so this is relatively simple. This is 40 over 100 divided by the square root of 75. And through the magic of math and computers, I can tell you that the answer here is 3.46. This is equal to your Z statistic. So number 8 is done. And then you could actually come back over here to your list and put Z is equal to 3.46. Z is equal to 3.46, right? Okay, so that's good. So that's number 8. Let's do number 9. Okay, at step 9, I'm going to encourage you to do something a little bit different. At step 9, oh, I want to be in white. At step 9, we are going to make a decision. But before we do that, anywhere along the way that you have trouble, I want you to remember this. When in doubt, draw it out. Okay? This is your new mantra. This is your new motto. It's not a motto, it's a mantra. Yeah, it's a mantra. Want it out, draw it out. You get to a place at any time during the process, draw it out. You're going to send me an email, and it's going to be like, Dr. Garcia, how do I do this? And I'll be like, I don't know. Do you have doubt? And he'll be like, yes, I have doubt. I'll be like, did you draw it out? And he's like, no, sir, I haven't drawn it out. Well, then draw it out. And that's going to be like 6 emails and like an entire afternoon, and nobody has time for that. So when in doubt, draw it out. So let's go ahead and draw our normal distribution. Let me scroll this up a little bit. I need more space. Need a little bit more space. Let's draw a normal distribution. Right, and I know that my normal distribution has 0.0250 on the outside. I know my normal distribution is a two-tailed deal, so I have 0.250 on the outside. And here at my z sub 1, I know that I'm at negative 1.96, right? We did that 2-3 steps ago. And I know that on this side I'm at 1.96. I know that at the halfway mark, my mu is equal to 0. And remember that this is a standard normal curve. The normal curve that you drew has a mu at 500, right? But this is a standard normal, so mu is 0, right? Because we're doing this z here. We're doing this z. Don't confuse your normal distribution with your standard normal distribution. It's a lot of stats 1 stuff there. And that's perfectly okay. All right, just remember that. All right. So, before we continue, we need to note at what points we are going to reject the null, because everything we're doing is about rejecting the null. Everything on the left, I am going to reject the null. Everything on the right of this z, I am also going to reject the null. How come? Because it's a two-tail test, right? 2 tails. I don't care if on average I'm on the right-hand side or on the left-hand side. I don't care if on average it is greater than 500 or on average it is less than 500. But there is this range. There is this range here between, actually that's not, there is this range here in the middle that says, as long as my average x bar is equal to 540 is in here somewhere, as long as I'm in here somewhere, I'm probably within the confidence intervals. I'm not probably within, I am within the confidence intervals. And here I cannot tell you for sure that I am different or different enough, that my x bar is not different enough from mu. Remember, my x bar was 540 and the average for the entire country was 500. So long as this is within, that this is somewhere close to here, then I can't tell you that that's really that different. So I am going to fail to, let me change the thickness on this guy. Let me change the thickness on this guy. Fail, I didn't really do it, to reject the null hypothesis, okay? We want to be on the outsides, all right? Let's see where we actually are. Well, where are we? I don't know. Well, what is the calculation? What is my z? My z is 3.46, right? Note that we have calculated lower extreme, upper extreme, and my z is 3.46. Right? Let me scoot this over so everybody can see it. I am way off on the right-hand side. Anything on the right over here, I'm going to reject. My z is right of this guy. And so my conclusion is to reject the null. Right? That is step 9. Let's go to step 10. Step 10 is state the conclusion. Because I am rejecting the null, rejecting, that's an R, rejecting the null, then let's write them again. H sub 1 is that the mu is equal to 500, and H sub 0 is that the mu is not equal to 500. So I am turning around and I'm saying reject the null. So this one's out. So this one is an acceptable decision. So my conclusion is there, let me do it in white. There is a difference between the average textbook cost of the U.S. population, U.S. student population, whatever, and the cost of textbooks at university of choice. Okay, so what have we proven? We've proven that there is a difference. We haven't proven that it is greater than or less than, right? That's not what we tested. You can tell, because this guy's way off on the right, you can tell it's probably greater than, right? But that was not the test that we did. We conducted whether or not there is a difference, and now there is a difference. So you go back into the chancellor's office and you say, there is a difference between our textbooks and that textbook, and then we can move forward with, you know, some new policy or state of concern or whatever it is. Hope that was helpful. Let me know if you have any questions.